Welcome to day 3 of our circles packet. Today we're going to start a series of notes dealing with arcs and angles that are created by the circle and the edge of the circle. And we'll be spending 3 or 4 days doing these various formulas, and I'm going to break them down into one per day. Today we're specifically talking about what an arc is, and then we're going to talk about central angles. So the edge of a circle, the curvy part, this part that travels all the way around the boundary line of the circle, a piece of that circle is called an arc. And this one in particular is about 1/4 of the boundary line in a circle, but they can be various sizes. They can be big, they can be small, but all of the arcs add up to 360 degrees in a circle. If you think about back to our triangle days, how all of our triangles added up to 180, you can kind of use that mindset for helping you understand the arcs adding up to 360. Now, if you look at the picture about midway down, it shows you an arc starting at point A and ending at point B. And we will name this arc AB with a little arc above the two letters. If you notice, when we look at point A and draw the radius, and we look at point B and draw the radius, this actually makes an angle that we're going to be talking about in this section called a central angle. And the thing about this angle and this arc that relates the two together are these points, A and B. Those are the points that the angle touches on the edge of the circle. Now, if we consider that this arc could potentially look different, just because it has those letters, doesn't mean it's always going to look that way. If we look at this red and blue and green circle on my screen, I believe it's black and white in your packet. This circle actually shows two different arcs. We have a minor arc, which is smaller, and a major arc in the blue, which is much bigger. It also shows an angle called a central angle. Right here, I'm going to highlight that in green, whose vertex is the center of the circle. So remember, the vertex is the pointy part of the angle. And this angle is called a central angle because of where its vertex is. The vertex is on the center, so they call it a central angle. Now, how do we know if something is a major arc or a minor arc? Well, here it says, and I'm going to highlight it, a major arc is an arc that is bigger than 180 degrees, and a minor arc is an arc that is smaller than 180 degrees. And I'm going to name both of these arcs down here below. So the minor arc we named up above. We're going to name that AB. So I'll write that in red because that goes with the red arc. And then the major arc, we're going to need a third letter. So we name the arc the way that we travel the arc. So if we start at A, we're going around the blue part, we come to point D, and then we come to point B. Or we could have started at B, traveled around come to point D, kept on going, and ended at A. And we could have done the same thing for the minor arc. We could have called that arc BA. Either one would be correct. The thing to understand about the major arc is that the D is part of the way around that arc. So we want that to be in the middle. I find it easier just to think that I'm kind of walking that way. And so I'll start at one point, I'll go past another point, and I'll end at the other point. So here's another picture of the minor arcs and the major arcs, but it also shows you a new vocabulary word right here called a semicircle. And that semicircle means half of the circle. And if you notice, it starts at one end of the diameter. Here's your diameter. Starts at one end of the diameter and goes to the other. So these semicircles are exactly half of 360, which is 180. So minor are less than 180, major are bigger than 180, and semicircles are half, exactly half, and they are exactly 180. So what happens with these central angles? Well, here's the central angle in this particular example. We have central angle ABC. And what we learn here in the geometry theorem is that whatever the angle is, so this angle is exactly the same as the arc. So when the vertex of an angle is located on the center of a circle, the angle measure is equal to the arc measure. And this means that the central angles also add up to 360 degrees, just like the arcs do. So I'm going to look at a couple of very easy examples here at the bottom of page 12. When we come back, we're going to do some tougher examples, but these are just sort of to get you started. If you look here, you can see that I have one angle that is X, another central angle that is 105, another central angle that is 60, and another central angle that is 115. And they make up the whole circle. So we can write a formula that adds them up to 360. And then we can go over to the Desmos calculator. Numbers, we have 105, 115, and 60. Now I don't see my answer, but again, I might have to zoom out. Nope, I'm not seeing that. Wonder why. Maybe I need to zoom out a little bit more. There we go. Just had not zoomed out enough. And my answer will be 80 for X. Sometimes you got to zoom out a little ways because 360 is a pretty big number. Okay, so that means that this angle here is 80. Now, what this also means for these arcs is that if this angle is 105, this arc from here to here is 105. This arc is also going to be 60. This arc is going to be 115. And this arc is going to be 80. So when the vertex is on the center, this is the easiest of all situations because everything just adds up to 360. There's no real major formula to remember because the angles and the arcs are the same size. Here we have a 90 and an X and a 120. So we have 3 central angles. That add up to 360. So again, I'll go over to my Desmos calculator. Let me just make sure I have my numbers right. Let's see, 120. And I can see my answer sticking over here. It's 150. So that angle X is 150 degrees right here. And so is its arc. This arc is 90. And this arc is 120. So when we come back, we're going to be on page 13. And I'm going to show you how to find the arcs, which is really easy because they're the same as the angles. And we're going to go back and forth interchangeably between the angles and the arcs, because in this particular scenario, this is the easiest scenario. Okay, I'll see you guys in just a couple. Thank you for listening.